Listed here are the steps for graphing a linear inequality. So feel free to pause the video and write this down. And I'm going to go through these, but it'll probably make more sense when we actually get to an example here in a second. But step one says you're first going to graph the corresponding equation. You're going to use a dashed line if it's greater than or less than. You're going to use a solid line if it's greater than or equal to or less than or equal to. After you graph your line with either dashed or solid, then you're going to test a point in one of the half planes. Half plane means when you draw your line, you're breaking your coordinate plane into two halves. You're going to test a point to figure out which side makes the inequality true, and then you're going to shade one side or the other. Now, I know that might not make a lot of sense now, but let me kind of relate it back to something we've done before. We've had to graph things on a number line when we're talking about one variable. So for example, if we said x is greater than 2, on a number line, I would draw a circle at 2. I would decide if it's an open or closed circle, in this case open, and then I'm going to draw an arrow in the correct direction. Well, if we're talking about the values greater than 2, we're talking about the values to the right. Well, this is similar, but this is in two variables. So you're going to kind of do the same thing. When it says graph the equation here, that's like drawing the circle. You're going to draw a line. So again, we're dealing now with an x-axis and a y-axis. And it says you're going to graph the equation. So maybe your line looks like this, and you're going to make it dashed because it's either greater than or less than. Now notice it breaks this into two halves. We have this side over here, and we have this side over here. You're going to test a point on one of the sides. Here's a hint. Whenever possible, use the origin. Use the test point 0, 0. The only time you cannot use it is if 0, 0 lies on your line. Now, when you input 0, 0 for your x value and your y value, if it makes it a true statement, you shade the side of the line that includes 0, 0. If 0, 0 doesn't make it a true statement, you shade the opposite side of the line. So let's look at an example. This says sketch the graph of x is greater than or equal to 1. Graph the corresponding equation. What that means is graph x equals 1. So on our x-axis, x equals 1 right here. But we're graphing a line. If you think back, we know that x is a vertical line and y is horizontal. Or you can think of it this way. X is always going to have to be 1. So if I'm going to draw another point, I need to do it where the x value is 1. Okay? Or just remember that x is a vertical line. So what you're going to do is you're going to draw a vertical line because it's x equals through x where x is 1. I'm sorry, where there's 1 on the x-axis. Now, you need to decide if this should be a solid line or if you need to draw a dashed line. If it's greater than or equal to or less than or equal to, the hint here is this equal to, you make a solid line. Okay, if that equal to wasn't there, you'd have to draw a dashed line out. Okay, so now we've covered big step 1 here. We've graphed the equation, we've used a solid line. Now we're going to test a point. Remember my hint, you want to test the point 0, 0, because that's usually the easiest to test. And now you go back to your inequality here, where it says x is greater than or equal to 1. In this case, we have no y value, so I'm going to substitute just an x. Or I'm sorry, just 0 in for x. Okay, so I'm substituting this point, we just don't have a y value. So when I put 0 in for x, I get 0 is greater than or equal to 1. And I want to know, is that a true statement or not? Is 0 greater than 1? No. So you test the point. If it's a solution, shade the half plane it's in. If it's not, shade the other half plane. Well, we said that this is not true. So since 0, 0 is on the left side of the line, we are going to shade the right side. Now, I'm not looking for a beautiful job of shading. Just kind of fill it in so you can understand. Try to be a little bit neater than I'm being maybe and not cross over the line. But what this is doing now is this means any point on this side of the line is a solution to this equation. So if I pick the point 5, 2. If I were to plug a 5 in right here, I would get 5 is greater than or equal to 1. True statement. Any point that falls in the shaded line or on the line would make this true. Let's look at this example. Sketch graph of y is greater than -3. Again, the first thing we're going to do is graph the equation y equals 3. Hopefully remember that y equals 3 is a horizontal line, and I apologize, this is -3, is a horizontal line through -3, which would be right here. So you just draw a horizontal line through -3, and before you do that though, you check right here. Since it's just greater than, it's kind of like an open circle, you're going to do a dashed line. I apologize for not making this more neat, but you get the idea. Okay, so we have a dashed line through -3. So we've drawn our horizontal line. We've decided it's dashed because it's just greater than, kind of like an open circle. And now we have to decide which side of the line are we going to shade. So if we look at y is greater than -3, test point 0, 0, if I plug my y value of 0 in, I get is 0 greater than -3? Is 0 greater than -3? Yes, 0 is greater than -3. So since this point makes it a true statement, yes, it's a solution, you're going to shade the side of the line that contains this point. So we're going to shade over here. Okay. So this graph represents y is greater than -3. Again, you can pick any point here. If you plug in that y value, it'll be greater than -3. Now that's what it looks like for a horizontal line and then a vertical line, or vertical line then horizontal. But what if you're given something like this, where it says sketch a graph of x minus y is less than or equal to 2? We want to start by graphing x minus y equals 2. Now there's a couple different ways you can solve this. You can make an input-output table and substitute values in for x and get out your output of y. You can find the intercepts. So I put 0 in for x, find out what y is, put 0 in for y, and find out what x is. Or we can put it into slope intercept form, which is actually what I'm going to do. But remember, all three methods are effective. So I'm going to put this into slope intercept form, y equals mx plus b, by subtracting x from each side. Not forgetting that this is a negative y, or a -1y, equals 2 minus x. You can think of it as plus and -1x, however you want to think of it. I'm going to divide both sides by -1. -1 divided by -1 is 1y, equals 2 divided by -1 is -2, plus -1 divided by -1 is a positive 1x. Okay? And if you're more comfortable, you can write the x term first, 1x plus a -2. Remembering that this is y equals mx plus b. Now we can graph this line right here, remembering that -2 is our y-intercept, 1 is our slope. So if you want, you can write it as 1 over 1. Before I graph it though, I'm going to peek back at my inequality symbol. Since my inequality symbol is less than or equal to, it's going to be a solid line. Now, I do have to caution you because I realize I did just make one little mistake here. We're graphing this equation, but we have to remember we actually do have to treat it as an inequality, and here's the reason why. We're good up until this part right here. Remember, if we divide by a negative, we have to reverse the inequality symbol. Something I almost forgot. So if you're dividing by a -1, instead of it being less than or equal to, it becomes greater than or equal to. So you still have to follow your rules for solving inequalities. Basically the exact same thing as equations, except when you divide by a negative, you just basically flip the inequality symbol over. Okay, so I peek here, but I do know that it's going to be a solid line because it can be equal to. So now we still have our y-intercept of -2 and our slope of 1/1. So our y-intercept is -2 and our slope is 1/1. Remember, slope is rise over run. So rise 1, run 1. Rise 1, run 1. And again, if you picked a different method of graphing, you could still do it the same way. You'd still get the same line. Okay. So we end up with a solid line just like that. And again, it's solid because it can be equal to. Now though, we need to test a point. Let's test the point 0, 0. X value of 0, y value 0. So if we go here, back to our original equation, we say, okay, 0 minus 0 is less than or equal to 2. And I realize now that we really didn't need to worry about the inequality over here because we are going to refer back to the original equation. So I apologize for that. It didn't hurt anything, but you don't have to worry about the inequality because as long as you go back to the original equation to substitute your x and your y value. Okay, so is 0 minus 0 less than or equal to 2? Is 0 less than or equal to 2? Yes, so 0, 0, the point 0, 0, is a solution. And if you would have put it into your resulting equation here, 0, 0, you would have gotten 0 is greater than or equal to 1 times 0 plus -2. And that would have worked out to be 0 is greater than or equal to -2, which is not true. It works though, because in this case we're saying it's greater than or equal to, and in this case we're saying it's less than or equal to. So I hope I didn't confuse you with that. You do not have to worry about the inequality symbol as long as you use the original equation to substitute your x and y value in. Focusing up here, we got 0, 0 as a solution. So since this point is a solution, we graph the side of the line that contains that point. So in this case, the sides, your half planes, aren't broken up into straight lines, it's diagonal. But we have everything kind of above and to the left of the line and everything below and to the right. So to recap, you graph your line and treat it like an equation. Okay. Once you get your line that you're going to graph, you take a peek to see if it's going to be a solid line or a dashed line. In this case, it was solid. Then you pick a test point, 0, 0 if possible. If it makes your original equation true, you shade the side of the line it contains. If it were to make your original equation false, you would shade the opposite side of the line of 0, 0.